Welcome everyone. I'm Majid and you're watching Lucid Mind. Today we'll solve paper 12 from May-June 2024. Let's start. Question 1. Which pair of formula is correct? We have Ag2CO3, which is silver carbonate. For the formulas, let's look into the charges. So Ag is positive, carbonate is 2 negative. So it becomes Ag2CO3. This is correct. We have ammonium nitrate. Ammonium ions is NH4 positive, nitrate is negative. So positive negative cancels out and it should be NH4NO3. Then we have potassium hydrogen carbonate. So K is in first group, it is +1, hydrogen carbonate is -1. So formula should be KHCO3. Then we have zinc phosphate. Zinc is 2 positive, phosphate is 3 negative. So 3 comes over here, 2 goes over there, it becomes zinc 3, phosphate 2. Then we have silver hydrogen carbonate. Silver is plus, hydrogen carbonate is minus. So AgHCO3. Potassium phosphate, K is +1, phosphate is -3. So 3 goes over there, so it becomes K3PO4. These are correct, so C might be the right answer. Let's look at zinc carbonate and ammonium phosphate. So zinc is 2 positive, carbonate is 2 negative. It becomes zinc carbonate. Ammonium phosphate, ammonium is +1, phosphate is 3 minus. So it should be NH4 3 PO4. Correct answer is therefore C. Question 2. How many molecules are present in 62 grams of solid white phosphorus P4? To find number of molecules, we must first find moles. Formula is moles is equal to mass in grams divided by mR. Mass in grams is given 62 grams. mR of P4 we can calculate by multiplying the atomic mass of phosphorus, which is 31, into its number of atoms, which is 4. So this is equal to 0.5 moles of P4. Alright, now let's find the number of molecules. So as we know that 1 mole of any substance contains Avogadro's number of particles. Avogadro's is also denoted by capital L, which is 6.02 into 10 to the power 23. So we have 0.5 moles, which would be the half of this. So 0.5 moles will be half of L and half of this. So this divided by 2 means 3.01 exponential 23. So correct answer is C. Question 3. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown in graphs. We have ionization energy and electrons removed. Again, ionization energy against electrons removed. What is the formula of ionic compound formed from these elements? Let's find out which element is this. So we have 1, 2, 3, 4, 5, 6, 7 ionization energies, and then after that there is a huge jump, which means that this 8th electron, it is from inner shell, because inner shell is closer to the nucleus, so the electron present in inner shell requires more energy to be removed. So first 7 electrons are present in outer shell. So when there are 7 electrons in outer shell, it means it is group number 7, which is halogens. In second diagram, we can see that there is a larger jump between second and third ionization energy, which means the third electron is from inner shell. So there are two electrons in outer shell, these two. So two electrons in outer shell means group number 2. Alright, let's look into the given options. We have group 2, group 7, group 2, group 7. We have group 1, group 6, group 1, group 6. So these two are wrong. So it might be magnesium chloride or calcium bromide. Alright, let's see if it is magnesium or calcium. For that, we have to look at the period number, as it says that these are present in period 3 of periodic table. So magnesium is present in period 3. Chlorine is also present in period 3 of the periodic table. Calcium is present in period 4. Bromine is also a member of period 4 element. So correct answer is A. Question 4. In which pairs are both species free radicals? Free radicals are those options in which we have unpaired electrons present. So let's see, we have Cl, Cl minus, Cl and Cl plus. So we have electron deficient, neutral, electron rich. Let's do the electronic configuration of all three types. Electron deficient, neutral, electron rich. Atomic number is 17 for each. Number of electrons differ. There are 16 electrons in the first one as it is positively charged, 17 electrons because it is neutral, and 18 electrons in this one. Alright, so let's do the configuration. We have 1s2, 2s2, 2p6, which makes it 10, 3s2, 12, and 3p4. So we have 3px, 3py, 3pz. There are 4 electrons, 1, 2, 3, and 4. So we have 2 unpaired electrons. It means Cl positive is a free radical. Now chlorine neutral. It will be similar till 3s2. So we have 12 electrons. Then after that we have 3p5. So 1, 2, 3, 4, 5. Still one electron is unpaired, so Cl is also a free radical. Then we have electron rich one, Cl negative. Same electronic configuration for the first part until 12. Then we have 3p6. One, two, three. Now pairing starts. 4, 5, 6. So no unpaired electron is present. This is wrong. Alright, let's look at oxygen. Same manner. Electron deficient, electron rich, neutral, etc. So we have O, 2 positive. We have neutral oxygen. We have -1 and we have -2. Atomic number of oxygen is 8. So we have 6 electrons, we have 8 electrons, we have 9 electrons, and we have 10 electrons. Let's do the electronic configuration. So 1s2, 2s2, 2p2. So we have unpaired electrons for O2 positive. Second one is 1s2, 2s2, 2p4. 1, 2, 3, 4. There are 2 unpaired electrons, so this one is also correct. Then we have -1, 1s2, 2s2 and 2p5. One, two, three, four, five. One unpaired electron is present. Then O2 negative, 1s2, 2s2 and 2p6. So 1, 2, 3, 4, 5, 6. No unpaired electron is present. So 1, 3 and 4 option is correct. Answer is A. Question 5. Which shape is correctly predicted by valence shell electron pair repulsion theory? We have to find number of bonded electron pairs, number of lone pairs and shape. So let's do it by the help of some examples. So let's suppose we have CO2. CO2 is linear. In CO2, a carbon makes double bond with one oxygen and a double bond with another oxygen. Carbon has only 4 electrons in the outermost shell, all of which are involved in bonding. So number of lone pair is 0. And number of bonded electron pairs is 2, which is also wrong. It is 4. There are 4 bond pairs of electrons and 0 lone pairs of electrons present with carbon. Second shape is tetrahedral. We can take another example. Let's suppose you have CH4. This is tetrahedral. So in CH4, one carbon makes bond with 4 hydrogen atoms. We have 4 single covalent bonds. There are no lone pairs of electrons present around carbon because all 4 electrons are involved in bonding. So this is also incorrect. And number of bonded electron pairs is 4, not 2. Then we have third example, pyramidal. For pyramidal, we can take ammonia. In ammonia, nitrogen makes 3 bonds with 3 hydrogen atoms. And we have a lone pair. So 1 lone pair, 3 bond pairs and pyramidal. C seems to be correct one. Then we have trigonal planar. For this one, we can take example of BF3. Boron makes 3 bonds with 3 fluorine atoms. Boron is present in third group of the periodic table, so it has only 3 electrons in the outermost shell. All of them are involved in bonding. 3 bond pairs, 0 lone pairs. So C is the correct answer. Question number 6. In which species does the underlined atom have incomplete outer shell? We have different options. Let's start with BF3. Boron is present in group 3. It has atomic number 5. So there are 3 electrons in the outermost shell. Boron makes 3 single covalent bonds with 3 fluorine atoms. The inner shell's 2 electrons are not involved in bonding. Now we can see that in total there are 6 electrons around boron atoms. So 6 electrons means it is electron deficient. It does not have a full octet, so A is the correct option. Then we have B, CH3 negative. Carbon's atomic number is 6. 4 electrons are present in the outermost shell. 1, 2, 3, 4. In CH3 it forms 3 bonds with 3 hydrogen atoms. 1, 2, 3. It says that we have a negative charge. So negative charge means 1 extra electron is present. So in total 1, 2, 3, 4, 5, 6, 7, 8. The octet is complete. Third one is F2O. Let's say with oxygen the atomic number is 8. So there are 6 electrons in outermost shell. 1, 2, 3, 4, 5, 6. 2 electrons are bonded to 2 fluorine atoms, making single covalent bond each. Now this is OF2 and we have 8 electrons. Last one is H3O positive. So let's look at oxygen again. 8 electrons. We have 6 electrons in outermost shell. Two electrons are bonded to two hydrogen atoms via single bond. We have H plus also present. So one lone pair, it is making a coordinate covalent bond with electron deficient H positive. Okay, so let's see 2, 4, 6, 8. 8 electrons are complete. So correct answer is A. Question 7. In this question, it should be assumed that nitrogen behaves as an ideal gas under the conditions stated. Which volume is occupied by 1 grams of nitrogen at 50 degrees Celsius and a pressure of 120 kilopascals? So for ideal gas, we can use ideal gas equation, which is PV equals to nRT. V is the volume. So volume equals to N, which is number of moles, R ideal gas constant, T temperature in Kelvin divided by P pressure in pascals. Let's put in values. So N is number of moles. Let's find moles of nitrogen. We have 1 grams. Moles is mass in grams divided by mR. Nitrogen is N2. 14 into 2 is 28. So 1 over 28. This is the moles. So instead of N, we can write 1 over 28. R is 8.31, a constant. T temperature in Kelvin. Let's convert this one to Kelvin. 50 degrees Celsius plus 273. 323. Over pressure in pascals, it is kilopascals, so we can multiply this by 1000 to make it pascals. So it is 120,000. By calculations, this one is 95.86 over 120,000, or it is equal to 0.000798. Now volume in ideal gas equation is always in meter cube, so we have meter cube. In given options, we have to find it in decimeter cube. So we can convert meter cube into decimeter cube by multiplying with 1000. It comes equal to 0.798 decimeter cube. So correct option is B. Question 8. Consider the following 4 compounds. We have these 4. What is the order of increasing boiling point of the compounds? You have to find out which one is highest and which one is lowest. Let's draw the structures first. So in first one, we have 3 CH3 groups attached to a CH. So this one is branched. Second one is CH3, CH2, CH2 and OH. Then we have CH3, CH2, CH2, SH. And then last one is CH3, CH2, CH2 and CH3. Alright, so let's see what are the intermolecular forces in all these. So we can see in second one we have electronegative oxygen, which is directly bonded to hydrogen. So because of the presence of this, there must be hydrogen bonding. And hydrogen bonding is the strongest intermolecular force of attraction, so this must have highest boiling point because the others do not have any fluorine or oxygen or nitrogen directly bonded to hydrogen atom. So 2 must be highest. So 2 should be the highest one. Now let's look at whether 1 is the lowest or 4 is the lowest. So in 1 we have branched structure, in 4 we have straight chain. Now there are more contact points in straight chain between two molecules as compared to branched chain. There are less contact points. So due to more number of contact points, the boiling point increases because more intermolecular forces are present or more van der Waals forces are present. So 4 must be higher as compared to 1. So 1 is the lowest. Then we have third one which is left. So in third one we have CH3, CH2, CH2, SH. So instead of carbon we have sulfur. Sulfur has more electronegative nature as compared to carbon, so it has higher boiling point than this one. So 1, 4, then 3 and then 2. Correct answer is B. Ethane can react with fluorine to produce 1,2-difluoroethane, C2H4F2. This is the equation. Enthalpy change is negative. Bonds are given. Energy is given in kilojoules per mole for each bond. What is the bond energy of CF bond in 1,2-difluoroethane? CF is absent, so we have to find that. Let's draw the structures first. So we have C2H6. There are 2 carbons, 6 hydrogen atoms. And we have F2. So F2 means fluorine is bonded to another fluorine and we have 2 moles. Alright, let's look into the number of bonds and let's put in values. So 1 carbon-carbon bond is present. 1 into CC. CC is 350, so 1 into 350 is 350. 6 carbon-hydrogen bonds are present. So 6 into CH. So 6 multiplied by 410. So it is equal to 2460. Then we have 2 FF bonds, so 2 into fluorine single bonded to fluorine. 2 into 158. It is 316. So adding all these three, 2460 plus 316 plus 350, it is equal to 3126. Let's move to other side. We have C2H4F2, so 2 carbons, 4 hydrogens, and 2 fluorine atoms. We have 2 moles of HF. Let's put in values the same way. So we have 1 carbon bond, so 350. 4 carbon hydrogen bonds, so it's 1640. 2 carbon fluorine bonds, which we have to find out, and 2 HF bonds. So 2 into 562, which is 1124. Adding these three, 350 plus 1640 plus 1124, we have 3114. And there are two CF bonds as well. Enthalpy change is given, it is minus 960. We can use formula. Enthalpy change of any reaction is equal to bonds broken minus bonds formed. Reactant bonds are always broken and product bonds are always formed. So we have reactant energy, which is 3126, minus bonds formed, which is product energy 3114, and we also have two CF bonds. Let's calculate this. So minus 960 equals to 3126 minus 3114 minus 2 CF. Let's take it over there. So 2 CF bonds will be 3126 minus 3114 plus 960. Let's calculate this. So 2 CF bonds, they become equal to 972. Now we can divide this by 2 on both sides. So 1 carbon fluorine bond is equal to 486. So we had to find bond energy of single CF bond, which is 486. Question 10. Which equation has an enthalpy change equal to the standard enthalpy change of formation of sodium oxide? Now, standard enthalpy change of formation means when 1 mole of sodium oxide, which is Na2O, is formed from elements in their standard states. Okay, so let's see which one is 1 mole. This is half moles, wrong. 1 mole, correct. 1 mole, correct. 2 moles, wrong. So we have two options, B and C. Let's see, we have correct elements in their correct states. So sodium is solid, oxygen is gas. Yes. Now let's look at the balancing. So 2 sodium atoms are present and we have 1 sodium, which is wrong. 2 sodium atoms are present, 2 sodium, so it is balanced. 1 oxygen and half O2 means 1 oxygen. So C is the correct one. Question 11. Nitrogen dioxide reacts with water. It forms HNO2 and HNO3. Which statement about this reaction is correct? We have to find both products are formed because oxygen atoms gain electrons. Nitrogen atoms undergo disproportionation. Oxidation number of hydrogen is increased. Water acts as an oxidizing agent. So to solve this, let's find out the oxidation number of each element. So in NO2, NO2 is overall neutral, so it is 0. 2 oxygens means minus 4. Nitrogen is plus 4. In water, hydrogen is always plus 1, oxygen is minus 2. In HNO2, overall charge is 0, hydrogen is plus 1. 2 oxygens minus 4. So minus 4 and plus 1 becomes minus 3. And it is plus 3. HNO3, overall charge is 0, plus 1, nitrogen, 3 oxygens. So minus 6 plus 1 is minus 5, or it becomes plus 5. Okay, let's write it down. So nitrogen is plus 4, nitrogen is plus 3, nitrogen is plus 5. Let's write down the others. Oxygen is minus 2 for single atom, hydrogen is plus 1, oxygen minus 2, plus 1, minus 2, plus 1, minus 2. Okay, so both products are formed because oxygen atoms gain electrons. Now we can see the oxidation state of single oxygen atom does not change on the reactant and product side, so this is incorrect. Nitrogen atoms undergo disproportionation. Disproportionation means self-oxidation as well as reduction. So nitrogen goes from +4 to +3, which is reduction. Also, it goes from +4 to +5, which is oxidation. So yes, this is disproportionation. The oxidation number of hydrogen is increased. This is wrong because it remains +1. Water acts as an oxidizing agent. No, NO2 is oxidized as well as reduced, so it is not oxidizing agent. Correct answer is therefore B. Question 12. Phosphorus reacts with concentrated sulfuric acid to produce phosphoric acid, sulfur dioxide and water. Equation is given. A, B, C and D and E are all whole numbers. Equation can be balanced by using oxidation numbers. Find this value of the sum of A, B, C, D and E. Let's find out oxidation numbers. Hydrogen is +1, oxygen is -2. Phosphorus is element, so it is 0. Hydrogen is +1, oxygen is -2. There are two oxygens, so -4 and sulfur will become +4. For one oxygen, we have -2. Hydrogen is +1, oxygen is -2. So let's find oxidation state of sulfur in H2SO4. H2SO4 has 0 charge, 2 hydrogens +2, 1 sulfur, 4 oxygens is -8. So sulfur is -6 or it becomes +6. Alright, so let's see the change. Sulfur, it goes from +6 to +4. So the change is 2. And we can see phosphorus. Let's find out phosphorus first. So H3PO4 is neutral. 3 hydrogen is +3, 1 phosphorus, and 4 oxygen is -8. So phosphorus -5, then phosphorus will become +5. So phosphorus, it moves from 0 to become +5. So the change is 5. Let's equalize this change. So we can multiply it by any number. So let's suppose 5 when multiplied with 2, it becomes 10, which will be equal if 2 is multiplied with 5, it will also become 10. Let's rewrite the equation and we can use these as balancing numbers. Okay, so we have H2SO4, phosphorus, H3PO4, sulfur dioxide and water. Okay, these two should be multiplied with 5, so which means that 5 moles of H2SO4 forms 5 moles of SO2. These two should be multiplied with 2, so we have 2 moles of phosphorus and 2 moles of H3PO4. Now let's balance by inspection method. Sulfur is 5, balanced. Phosphorus is 2, balanced. Hydrogen is 10, 5 into 2 is 10, so there are 10 hydrogens. 3 into 2 is 6, so we need 4 more. So if we multiply water with 2, it will become 4. Hydrogen is balanced. Oxygen is 20. We have 8 and 10, 18 and 2, 20. So everything is balanced. Let's sum it up. So 5 plus 2 plus 2 plus 5 plus 2. So 10, 12, 14 and 16. Correct answer is D. Question 13. The volume of ammonia produced against time is measured in two experiments. Nitrogen and hydrogen forms ammonia. Enthalpy change is -92. In experiment 1, 3 moles of hydrogen, 1 mole of nitrogen react together at 45 degrees Celsius and a pressure of 200 atmosphere. This is experiment 1. A graph showing the volume of ammonia produced against time is plotted. Experiment 2 is then performed. Experiment 2 differs from experiment 1 in one condition only. So let's write down the conditions for experiment 1. We have 45 degrees Celsius and 200 atm. How does experiment 2 differ from experiment 1? Okay, let's see what is the difference here. So here we can see that experiment 1, it has more volume of ammonia as compared to experiment 2. So we can see we have greater yield. Of NH3. And if we look at this side, we can see that experiment 2 is more steep, so it is faster as compared to experiment 1. Experiment 1 is slower. So for experiment 2, we have to find the conditions which produce less yield and faster reaction. Alright, so part A, an iron catalyst is present in experiment 2. Because of the presence of catalyst, speed increases. So one part is true, we have faster reaction, but yield does not change. Catalyst never changes the amount of product formed. So it is incorrect. Part B, 2 moles of helium gas is present in reaction mixture in experiment 2. Now helium is unreactive gas, so it does not affect the rate of reaction. It does not change the yield. Part C, a pressure of 250 atmosphere is used in experiment 2. So pressure changes from 200 to 250. Let's see. We have 4 moles of reactants. We have 2 moles of products. So when pressure is increased, the reaction or the equilibrium moves in forward direction from more moles to less number of moles. So yield of ammonia should be more. So as compared to 200 atmosphere, if we use 250 atmosphere, it means a yield of ammonia should increase, but there is less yield. So this is wrong. Part D, a temperature of 600 degrees Celsius is used in experiment 2. Alright, let's see what temperature does. So we had 45 degrees Celsius in experiment 1. Now in experiment 2, we have 600 degrees Celsius. So higher temperature means we have more kinetic energy and faster reaction. So it will be more steep. This part is true for higher temperature. Now let's look at yield. As we can see in the equation, it has exothermic reaction. So for exothermic reaction, if you increase the temperature, the equilibrium shifts to the left side. So yield will become lesser. So in experiment 2, we have less yield and we have faster rate. So both things are possible if we increase the temperature. Correct answer is therefore D. Question 14, which reaction has an equilibrium constant Kp that has no units? Now Kp for any reaction can be written like this. Kp is equal to the pressure of products divided by the pressure of reactants. Pressure is given in pascals. So if we have equal pascals for reactants and products, they will cancel out and there will be no unit. Equal pascals are possible only when we have same number of moles of reactants as well as products. So let's see which one are same. We have 1 and 1 2 moles of reactants and 2 moles of product. So Pascal squared divided by Pascal squared cancels out. This one is correct. We have 4 moles for this one and 2 moles for this one, so they do not cancel out, so this is wrong. 2 moles on this side and 1 mole on this side, it also does not cancel out. 3 moles on reactant side and 2 moles on product side, so unequal. So if number of moles is same, Pascal unit is same, and there will be no unit. So we can do this. We have Kp, so pressure of hydrogen iodide, as there are 2 moles, so it is squared divided by pressure of hydrogen into pressure of iodine. So Pascal square for this one, Pascal for this one, Pascal for this one. So Pascal square divided by Pascal square is no unit. Correct answer is A. Question 15. Gas Q decomposes slowly at room temperature. Q forms X and Z. The Boltzmann distribution curve for gas Q at room temperature is shown. We have Boltzmann distribution curve. This is activation energy. We have number of particles on y-axis and energy of particles on x-axis. Which change occurs when catalyst is added to gas Q? Alright, so let's look at options. The peak of the curve moves to right on the diagram. Now the peak of the curve can only change to the right if temperature is increased. Catalyst does not change energy of molecules, so peak does not move. This one is wrong. The number of particles with enough energy to decompose increases. Okay, let's see what happens when catalyst is added. Catalyst reduces activation energy. So energy increases in this manner. So it means by adding catalyst, activation energy will become lower. So this much molecules were converting or getting decomposed before adding catalyst. Now after adding catalyst, the number of molecules in this range will increase. Now this many molecules, whole of this part will be converting into product. So yes, the number of particles with enough energy to decompose will increase. Part C, the kinetic energy of the unreacted particle increases. Now catalyst does not change kinetic energy. Kinetic energy is changed by temperature only. Value of EA decreases. This is true. First it was higher, now it is lower. Moving the vertical dotted line to the right on the diagram. No, if it goes to the right, it means activation energy increases. It should go to the left. Correct answer is therefore B. Question 16, which statement is correct? Part A, aluminum chloride has a giant ionic lattice of Al3 positive and Cl negative ions. Now for aluminum chloride, we know it exists in two different forms. One is AlCl3 having giant ionic lattice, and there are Al3 positive as well as Cl negative ions. It also exists in dimer form Al2Cl6, which has covalent as well as coordinate covalent bonds. So not only giant ionic but covalent structure is also formed. Part B, sodium chloride dissolves in water forming HCl and NaOH. This is wrong because sodium chloride is a neutral salt, so it dissolves in water to form aqueous solution, in which we have Na positive aqueous and Cl negative aqueous. No other products are formed, so this is incorrect. Part C, The strong covalent bonds in silicon chloride prevent it from reacting with water. Silicon chloride is SiCl4. It is in the form of liquid. It can react with water and get hydrolyzed. So SiCl4 hydrolyzes to form silicon dioxide and HCl gas. So this is wrong. Then we have phosphorus chloride added to water, resulting solution conducts electricity. PCl5. It is solid, it can react with water liquid to form H3PO4, which is phosphoric acid aqueous, as well as HCl gas. So this phosphoric acid aqueous is present in solution. It will form ions H positive and phosphate negative. So yes, it will become good conductor. Correct answer is therefore D. Question 17. A mixture of calcium carbonate, calcium nitrate, strontium carbonate, strontium nitrate is thermally decomposed. The decomposition reaction of each substance goes to completion. Each substance is anhydrous. How many different products are formed? Let's do the decomposition reactions. So first one is calcium carbonate. Calcium carbonate decomposes to form calcium oxide and releases CO2 gas. Then we have calcium nitrate, CaNO3 twice. Nitrate decomposes to form oxide, nitrogen dioxide gas, and oxygen gas. Then we have strontium carbonate, SrCO3, so strontium oxide and CO2. Then we have strontium nitrate, SrNO3 twice, decomposes to form strontium oxide, nitrogen dioxide, and oxygen gas. Let's see how many different products are formed. So calcium oxide, carbon dioxide, calcium oxide is getting repeated, nitrogen dioxide, oxygen, strontium oxide, carbon dioxide is repeated, strontium oxide is repeated, nitrogen dioxide is repeated, oxygen is repeating. So we have 5 different products which are formed. Question 18. W is a solid that reacts with water to produce an alkaline solution. The addition of 2 drops of dilute H2SO4 to this alkaline solution produces a white precipitate. What could be the identity of solid W? Alright, so let's see. We have magnesium hydroxide. Magnesium hydroxide reacts with water to form aqueous magnesium hydroxide, in which we have Mg2 positive and OH negative ions. Although the solubility is not much, but we have very small amount of these ions. Now when H2SO4 is added, it can react with magnesium to form magnesium sulfate. But magnesium sulfate is also soluble, so there is no precipitate. Second one is magnesium oxide. Magnesium oxide, when added to water, it forms magnesium hydroxide. So again the same thing. Magnesium hydroxide does not form any precipitate with sulfuric acid. Then we have barium oxide. When it is added to water, it forms barium hydroxide, which is highly soluble. So we have barium 2 positive, OH negative ions. In the presence of H2SO4, barium can form barium sulfate, and barium sulfate is insoluble solid. So this is a precipitate. Phosphorus oxide, it is non-metal oxide, so it forms acidic solution when added to water. P2O5 or P4O10, it can form H3PO4. So this is not alkaline solution, it is incorrect. Correct option is C. Question 19. Chlorine gas is reacted with cold aqueous sodium hydroxide. Which statement is correct for this reaction? So chlorine is oxidized reduced, neither oxidized reduced. Let's find it out. First thing is the reaction of chlorine with cold dilute aqueous sodium hydroxide. It forms NaCl, NaClO, and water. Let's find out oxidation states. Chlorine is molecules, which is 0, Na is +1, Na is +1, Cl is -1, +1, oxygen is -2, hydrogen is +1, oxygen is -2. Let's find out the remaining one. So OH is overall negative. So oxygen is -2 and hydrogen is +1. Because -2 and +1, it is equal to -1. Let's find out Cl in NaClO. Overall, it is neutral. Na is +1, chlorine is Cl, oxygen is -2. So -2 and +1 becomes -1, which will become +1. Alright, let's see what happens to chlorine. So chlorine moves from 0 to -1. So this is reduction. Chlorine goes from 0 to +1 as well. So this is oxidation. So chlorine is both oxidized and reduced, and this is the correct answer. Question 20. Sodium is added to water to form solution Y. The pH of solution Y is measured. When powdered substance X is added to solution Y, the pH falls. Which two compounds could each be substance X? Let's see what happens. Sodium is added to water, so sodium metal reacts with water to form sodium hydroxide and releases hydrogen gas. This sodium hydroxide is alkali, so because of this, the pH is almost equal to 14. Let's see, when powdered substance X is added to solution Y, the pH falls, so which means that pH should decrease. First one is magnesium chloride. So when MgCl2 is added to this solution, which contains sodium hydroxide aqueous, it will form magnesium hydroxide and NaCl. Now sodium hydroxide is alkaline, it is fully soluble, so we have higher pH. Magnesium hydroxide is less soluble comparatively, so it means number of hydroxide aqueous ions are reduced, so pH will decrease. Let's look for aluminum hydroxide. Aluminum hydroxide is AlOH3. It can react with sodium hydroxide to form NaAlOH4 complex. So sodium hydroxide was more soluble and higher pH. This is less soluble, so pH decreases. Because hydroxide aqueous ions are now decreased. So aluminum hydroxide is also correct. Then we have potassium oxide, which is ionic compound, NaCl ionic compound, NaCl ionic compound. These are neutral salts and neutral oxides, so they do not affect the pH. So correct answer is A. Question 21. The table shows statements about some of the properties of halogens and their compounds and explanation for these properties. Which row shows a correct statement about the property and a correct explanation for the statement? Let's see the statements and their explanations. First one is that iodine is a solid at room temperature. This is true. Explanation is that the II bond strength is high. Now, being solid depends on the intermolecular forces of attraction, not the bond strength. This is wrong explanation. Part B, the decomposition of hydrogen iodide is more endothermic than the decomposition of hydrogen chloride. Now, if we see hydrogen chloride has more electronegative chlorine, hydrogen iodide has less electronegative iodide as well as greater size. So this is weaker bond, this is stronger bond. So hydrogen iodide is less endothermic. This is wrong statement. And the correct explanation is that chlorine is more reactive than iodine. This is also wrong because they should mention bond strength instead. Part C. When chlorine is bubbled into aqueous potassium iodide, a purple solution is seen. Alright, let's see. So chlorine is Cl2 and we have Ki aqueous. It forms, as chlorine is more reactive than iodine, so it can replace iodine to form KCl and I2. So iodide goes from -1 to 0. That is oxidation. And iodine is purple in color. So this is a true statement. Explanation is that chlorine is a stronger oxidizing agent than iodine. In this reaction, we can see we have chlorine and we have iodide. Iodide goes to iodine, not the other way around. KCl will not react with iodine to form these products. So it should be iodide. Part D, when concentrated sulfuric acid is added to solid potassium iodide, a purple vapor is seen. Let's see. So we have Ki and concentrated sulfuric acid. It reacts to form potassium hydrogen sulfate along with hydrogen iodide. This hydrogen iodide can further react with sulfuric acid. So it can form iodine plus sulfur dioxide plus water. Again, we have iodine formed, which is purple. So when concentrated sulfuric acid is added, purple vapor is seen. This is correct. Explanation: iodide ions are being oxidized to iodine by sulfuric acid. So let's see the oxidation state. Iodide is -1, iodine is 0. So -1 to 0 is oxidation. So it means H2SO4 is behaving as an oxidizing agent. True explanation. Correct answer is D. Question 22. Which statement describes the property of an ammonium ion? So part A, an aqueous ammonium ion is a weak Bronsted-Lowry base. Let's see, ammonium ion is NH4 positive. Let's suppose it can react with water to form ammonia and H3O positive. So in this case, we can see that ammonium ion has donated a proton to water to make it H3O positive. So proton donor is Bronsted-Lowry acid. Part B, aqueous ammonium sulfate reacts with dilute HCl to make ammonia gas. Now ammonium sulfate is ammonium salt. You can take any ammonium salt and react it with an alkali or a base to form ammonia. So we have salt, water, and ammonia. So we need base. An ammonium ion has a pyramidal shape with bond angle of 107 degrees. So ammonium ion is NH4 positive, 3 are covalent bonds, and we have one coordinate covalent bond with electron deficient hydrogen. So in total, overall charge is positive. As it is tetrahedral, all 4 bonds are same, so bond angle should be 109.5. This is tetrahedral, it is not pyramidal, and bond angle is not 107. The 4 nitrogen-hydrogen covalent bonds in ammonium ion are identical to each other. We can see we have covalent bonds, we have coordinate covalent bond, and they are the same. So D is the correct answer. Question 23. Catalytic converters are fitted in the exhaust systems of many cars. We have gas X, which causes acid rain if it is released into the air, and gas X is removed from car exhaust fumes by catalytic converter. What is gas X? We have carbon dioxide. First thing is acid rain. Second thing is to remove by catalytic converter. So carbon dioxide is acidic gas. It does form acid rain when it is released into the air because it is soluble in rain. Carbon monoxide, it is insoluble in water, so it does not form acid rain. Hydrocarbons are organic compounds, insoluble, so do not cause acid rain. Nitrogen dioxide is acidic oxide, so it is also soluble. It forms acid rain. Second part is that it is removed from car exhaust fumes by catalytic converter. So catalytic converter removes toxic gases. For example, carbon dioxide, it is one of the products, it is not toxic, so it is not removed. Carbon monoxide is removed as it is toxic. Hydrocarbon vapors, they are completely combusted in a catalytic converter to form CO2 and water. Nitrogen dioxide is removed from car exhaust by catalytic converter. So nitrogen dioxide at high temperature, it first converts into nitrogen monoxide and oxygen gas. This nitrogen monoxide, it can react with carbon monoxide in catalytic converter to form N2 and CO2. This is how it is removed. So correct option is D. Question 24. In the general formula of which class of compound is the ratio of hydrogen atoms to carbon atoms the highest? General formula for alcohols is CnH2n plus 1 OH. So we have more hydrogen atoms as compared to carbon atoms. This is true. Then we have aldehydes. The general formula is CnH2nO. Hydrogen is double as compared to, so this is also correct. Then we have carboxylic acids, CnH2nO2. Still hydrogen is more. And we have halogen alkanes, CnH2n plus 1 and a halogen. So in all of them, hydrogens are more as compared to carbons. Let's find out the ratio by looking at the real formulas of the smallest compounds possible. So for alcohols, we have one carbon alcohol, CH3OH. One carbon aldehyde, HC double bond OH. One carbon carboxylic acid, HC double bond OH. One carbon halogen alkane, let's suppose we have CH3F. Alright, let's look into the ratio of carbon and hydrogen atoms. So 1 carbon, 4 hydrogens, 1:4. 1 carbon, 2 hydrogens, 1:2. 1 carbon, 2 hydrogens, 1:2. 1 carbon, 3 hydrogens. So 1:3. The highest ratio in terms of hydrogen and carbon is 4:1 for alcohols. So correct answer is A. Question number 25, which statement is correct? Part A, adding sodium oxide to water gives a lower pH solution than adding silicon oxide to water. Sodium oxide is basic oxide. When it is dissolved in water, it forms sodium hydroxide. Sodium hydroxide is an alkali, a strong one, so it has a higher pH. Silicon dioxide, it is actually insoluble in water. Part B, the oxidation state of sodium in its chloride is higher than the oxidation state of silicon in its chloride. So sodium chloride is NaCl, Cl is -1, Na is +1. Silicon chloride is SiCl4, so 4 chlorine becomes -4, so silicon must be +4. So the oxidation state of sodium is lower. Third part, the atomic radius of sodium is larger than that of silicon. So let's see. If we look in period 3, we have sodium, magnesium, aluminum, and silicon in series. The atomic number increases from 11 to 14. Number of shells remains same. Shielding effect is same. So what happens? The nuclear attraction increases, so size decreases. So atomic radius of sodium is larger as compared to silicon, which is smaller. Part D, the melting point of the chloride of sodium is lower than melting point of chloride of silicon. Sodium chloride is a giant ionic compound. There are stronger electrostatic forces of attraction, so its melting point is higher. On the other side, we have silicon chloride SiCl4, which is actually covalently bonded simple molecular structure. Correct answer is therefore C. Question 26. Z is a gaseous hydrocarbon which has a density of 3.50 exponential -3 grams per centimeter cube under room conditions. Z reacts with excess of hot concentrated acidified KMnO4. Only one type of carboxylic acid is formed in the reaction. What is Z? So concentrated acidified KMnO4, it does bond cleavage where C double bond C is actually broken into different types of products. Let's suppose for first one we have but2ene, so 4 carbon atoms and double bond is present between second and third. If this thing is used, then what will happen? There will be bond cleavage. Now this carbon is bonded to a hydrogen atom and alkyl group, so it will become carboxylic acid. This carbon will also become carboxylic acid. So we have CH3COOH, 2 carbon carboxylic acid on one side, 2 carbon carboxylic acid from this part. So one type of carboxylic acid is formed. This might be correct. Next one is 2,3-dimethyl-but2ene. So we have but, which means 4 carbons are there. 2ene means double bond is between second and third. 2,3-dimethyl means one methyl group is on second carbon, one on third carbon. So again we can see that this molecule is symmetrical. The left side and right side, they are same. So again bond cleavage will happen. Now we have this double bonded carbon which is attached to alkyl group. So this kind of carbon converts into ketone. So we have CH3, C double bond O, CH3. The other product will also be similar, CH3. This carbon will be bonded to oxygen and CH3. So it does not make any carboxylic acid. This is wrong. Third part is hex-2-ene. Now hex means we have 6 carbons. 2-ene is again double bond between second and third carbon. This is unsymmetrical molecule, so products will be different. Let's do bond cleavage. Carbon is bonded to a hydrogen and alkyl group, so it will become carboxylic acid. This carbon is bonded to a hydrogen and alkyl group, so another carboxylic acid. We have 2 carbon carboxylic acid on one side and 4 carbon on the other side. So CH3COOH and 4 carbons. So 2 types of carboxylic acids are formed. This is wrong. Next part is hex-3-ene. So again we have 6 carbons. 3-ene means that double bond is present between third and fourth carbon. Rest are the hydrogens. Again this looks symmetrical. So left and right side are same, so same products will be formed. 3 carbon carboxylic acid on one side and 3 carbon carboxylic acid for the other side. Alright, so similar or one type of carboxylic acid is formed. Now we have 2 answers, either it should be A or D. Let's see what else is given. So it says that it has density of 3.50 exponential minus 3 under room conditions. Okay. So density is given in grams per centimeter cube. We can do the ratio. So grams against centimeter cube. So this much grams for 1 centimeter cube. So we can write 3.50 exponential minus 3 grams for 1 centimeter cube. Now let's see, we have room conditions. So what are room conditions? In room conditions, 1 mole of any gas occupies a volume of 24,000 centimeter cube. So if we want to find it for 1 mole, we'll have to use this much volume. So let's find mass in grams for 24,000 centimeter cube. We can cross multiply. Now x will be 24,000 into 3.50 exponential minus 3. So x will be equal to 84 grams. Now this much gram is for 24,000 centimeter cube per 24,000 centimeter cube. Now 24,000 centimeter cube is also 1 mole, so we can say grams per mole. Let's find molecular mass of these two and let's see which one is 84 grams per mole. For but-2-ene we have 4 carbons, so 12 into 4 is 48 plus 3, 4, 5, 6, 7, 8. 8 hydrogens, so it is 56. In terms of grams, we can say 56 grams per mole. For hex-3-ene, we have this one. So we have 6 carbons, 12 into 6 is 72, plus 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 84 grams if it was 1 mole. Now the density given is 84 grams per mole, which is similar for D. Question 27. Compound X can be oxidized to compound Y. Compound Y then gives a yellow precipitate with alkaline aqueous iodine. What is compound X? We have butane 1-ol, butane 2-ol. So in butane 1-ol we have 4 carbons. And 1-ol means that OH is present on the corner carbon. This is primary alcohol. So let's oxidize it first. Primary alcohol oxidizes to aldehyde and then to carboxylic acid. So we have 4 carbon carboxylic acid. Alright, now it says that compound Y, which could be this one or this one, gives a yellow precipitate with alkaline aqueous iodine. So we have aldehyde. For aldehyde, there must be a CH3 group directly attached to C double bond O, which is not present. So it won't give a precipitate. Carboxylic acid does not give precipitate. Part B, we have butane 2-ol. So now 4 carbon atoms are there. OH is on second carbon. So first step is oxidation. As it is secondary alcohol, it will be oxidized to a ketone. This cannot be further oxidized. So this might be compound Y, which gives a yellow precipitate with alkaline aqueous iodine. Now for that we need CH3 directly attached to C double bond O. This part is present, so it means it will give a precipitate with alkaline aqueous iodine. Third part is methyl propane 1-ol. So propane means there are 3 carbon atoms. 1-ol means OH is on first carbon. Methyl propane 1-ol means methyl is not part of long chain, so it must be on second carbon. Rest are the hydrogens. By oxidation, as it is primary alcohol, so it will be converted into aldehyde first. Now this aldehyde can be further oxidized to carboxylic acid, but that is not needed because carboxylic acid never gives a yellow precipitate with alkaline aqueous iodine. Okay, so for this part we need CH3 directly attached to C double bond O, which is absent, so this won't give positive result. Next part, methyl propane 2-ol. Again we have propane, so 3 carbons. 2-ol means OH is on second carbon. Methyl means CH3 is also not part of long chain. Let's do oxidation first. So as this one is tertiary alcohol, because OH is attached to carbon, which is attached to 3 carbons directly, so it will not get oxidized. Only correct option is then part B. Question 28. Aqueous sodium hydroxide reacts with 1-bromopropane to give propane 1-ol. What should be included in a diagram of the first step in the mechanism? Okay, let's see. We have 1-bromopropane, so 3 carbons for propane. Bromine is present on first carbon, 1-bromo. Rest are the hydrogen atoms. Bromine is partial negative because it is more electronegative. Carbon is partial positive as it is less electronegative. So we are going to react it with aqueous sodium hydroxide. Aqueous sodium hydroxide provides us with OH minus. Now what will happen? This oxygen, it will attack carbon and it will make a bond with carbon. These electrons will move towards bromine. So product form will be CH2, CH2, CH3. So OH is attached to CH2 and Br minus is substituted. Alright, so let's see. It says that a curly arrow from a lone pair on OH into the carbon partial positive atom of 1-bromopropane. This is correct. Curly arrow from carbon partial positive to the OH minus ion. This is wrong because curly arrow is always from negative to positive. a curly arrow from CBr bond to the C atom, CBr bond to bromine atom. It is not carbon atom because bromine is electronegative, so it will take away electrons. Homolytic fission of CBr bond, this is not happening here. So correct answer is A. Question 29. In which reaction is the organic compound oxidized? We have aldehyde, we have alcohol, primary alcohol, and we have ester. So first one is Tollens reagent. Tollens reagent is mild oxidizing agent. So it can oxidize aldehyde. LiAlH4, it's a powerful reducing agent. It cannot oxidize, it can only reduce. Concentrated phosphoric acid, when this is used with alcohol, it causes dehydration, which is the removal of water. And then we have dilute sulfuric acid along with ester. When this is used, it causes acid hydrolysis of ester. So the only part which is being oxidized is part A. Let's see. So as this is 4-carbon aldehyde, it will be oxidized to become carboxylic acid. Second part is again aldehyde. But this time it will be reduced with LiAlH4 to become primary alcohol. Third part is primary alcohol. So in the presence of concentrated phosphoric acid, dehydration is caused. OH is removed from one carbon and hydrogen is removed from adjacent carbon, and we have double bond between these two. So CH3 CH double bond CH2. Last one is ester. So CH3 C double bond O O C2H5. On acid hydrolysis, we have two parts as this bond is broken. So this part becomes carboxylic acid and this part becomes alcohol. So in products, we have 2-carbon carboxylic acid and we have 2-carbon alcohol. So oxidation takes place in only part A. A is the correct answer. Question 30. 1 mole of each of the following 4 compounds is reacted separately with an excess of sodium and excess of sodium carbonate. Which compound produces the same volume of gas with each of the 2 reagents? Okay, so we have alcohol, we have carboxylic acid, we have aldehyde, and again we have carboxylic acid. So alcohol, carboxylic acid, and aldehyde. 3 functional groups are present. Now sodium is a reactive metal. It can react with alcohol and it can also react with carboxylic acid. It does not react with aldehyde. Second part is sodium carbonate, which can react only with carboxylic acid part. Let's find out volume of gas formed. So in part 1 we have 2 carbon atoms present and both are attached to alcohol groups. So CH2, CH2, OH and OH. First reacting with sodium, alk oxide is formed, so sodium replaces hydrogen atom on both carbons. Two hydrogen atoms are removed, so 1 mole of H2 is formed. Second thing is sodium carbonate. Sodium carbonate cannot react with alcohol, so no gas will be formed. So we have 1 mole of hydrogen with one and we have 0 moles with other, so A is wrong. Part B, we have 3 carbons, CH3, CH, OH is present on second carbon, then we have COH. Let's first react with sodium, then when we can react with sodium carbonate. So with sodium we have CH3, CH, O negative and A positive. Sodium can also react with this part, so C double bond O, O negative and A positive. So 2 atoms of hydrogens are lost. It means 1 mole of H2 is formed with sodium. Let's react it with sodium carbonate now. So acid part will react. Acid plus carbonate makes salt, water and carbon dioxide. So this is the salt. Plus CO2 plus H2O. Alright, let's balance this equation first. We have 2 sodium atoms, so we need 2 with this part. 2 carboxylic acid is needed. And then carbon is balanced. Oxygen 4, 5, 6, 3, 4, 5, 6 balanced. Hydrogens 3, 4, 5, 6, 12, 3, 4, 5, 10 and 2, 12. So everything is balanced. Now we can see that CO2 is gas, H2O is liquid. So 2 moles of carboxylic acid will form 1 mole of CO2. So if we take 1 mole of carboxylic acid as we did in this part, so 1 mole will form half moles of CO2. In this case it formed 1 mole of hydrogen, but in this case it is forming 0.5 moles of gas. So both are not same. B is also wrong. Now let's look at C. We have 2 carbon atoms. One part is alcohol, one part is aldehyde. So CH2OH and C double bond OH. We have reaction with sodium and we have reaction with sodium carbonate. With sodium, OH will react, CH2, O negative and A positive. One hydrogen atom is lost. C double bond OH is unaffected. So when one hydrogen is lost, it means half moles of H2 is formed. With sodium carbonate, there is no reaction, so no gas is formed. So C is also wrong. Now we have D. In D, we have 2 carbons, and this is carboxylic acid. So C double bond O, OH on one side, C double bond O, OH on other side. Let's react it with sodium and sodium carbonate. We have excess of sodium, so product form will be sodium salt. One hydrogen atom is lost. Another hydrogen atom is lost. So 2 hydrogen atoms become 1 mole of H2. Now doing the same with sodium carbonate. C double bond O, O negative and A positive, sodium salt. plus CO2 plus H2O. Okay, now in this case, carbon dioxide is gas. So let's see how much CO2 is formed. We have two sodium carbonate, both sodium are now attached, carbons are balanced, and hydrogen is also balanced. So we can say that 1 mole of this carboxylic acid, it forms 1 mole of CO2. In this case, 1 mole of carboxylic acid forms 1 mole of H2. So both are 1 moles. So volume is same. Correct answer is therefore D. Question 31. Which reaction will distinguish between propane 1-ol and propane 2-ol? Alright, let's see. Propane 1-ol means we have 3 carbons and alcohol is on first carbon. This is primary alcohol. Propane 2-ol is alcohol having OH on second carbon, so it is secondary alcohol. First thing is warming with acidified KMnO4. So acidified KMnO4 is oxidizing agent. It will oxidize both of them. First part will become aldehyde or carboxylic acid. Second part will become ketone. So both will give positive result. We cannot distinguish. Second thing is warming with acidified potassium dichromate. This is also an oxidizing agent, so same reactions will happen. Aldehyde or carboxylic acid is formed in the first one, ketone is formed in the second one. So both have same effect. Third part is dehydration followed by reaction with bromine. Let's do dehydration first. So dehydration means removal of water. We have CH2, CH2, CH3, OH. And second one is CH2, CH, CH3, OH. So dehydration is done by removing OH from one carbon, hydrogen from adjacent carbon. You can choose any adjacent carbon. In this case, the answer will be similar. So the product formed will be CH2 double bond CH, CH3. In this case, it is going to be same CH2 double bond CH, CH3. This is actually 3 carbons. Okay, so same thing is formed. Next step is followed by reaction with bromine. Bromine adds itself up with alkene. So same product will be formed. Each double bonded carbon attaches one bromine to itself. So now we have CH2 with bromine, CH with bromine. Same for this part. So we cannot distinguish using these. Last part is mild oxidation followed by reaction with Valence reagent. Alright, let's do mild oxidation for primary alcohol. So it will become aldehyde. For this part, if we do mild oxidation, it will become ketone. So we have ketone, we have aldehyde. followed by reaction with Valence reagent. Now aldehyde gives positive result with Valence reagent, ketone does not. So yes, we can differentiate between these two on the basis of this reaction. So correct answer is D. Question 32. Compound T has skeletal formula shown. This is skeletal formula. Which structure is structural isomer of compound T? So we have to look for something that has same molecular formula but different structure. Alright, let's see. So we have the long chain. Rest are the substituents. This one is nearer to the corner, so let's start numbering from this end. We have 1, 2, 3, 4, 5, 6, 7 carbons in total. Methyl is on second one, third one, and fifth one. So the name should be 2, 3, 5. There are 3 methyls, so try methyl. And we have 7 carbons in long chain, so it is heptane. Alright. So in total we have 7 and 3, 10 carbons, C10. It is alkane, so CnH2n plus 2, it will be 22 hydrogens. Now let's see which one is structural isomer. First, let's look at the long chain. So 1, 2, 3, 4, 5, 6, 7. Again, 3 substituents. Let's do the numbering. This one is nearer to corner carbon, so we have 1, 2, 3, 4, 5, 6, 7. Methyl group is on second one, third one, and fifth one, so it is 2, 3, 5. Try methyl heptane. We can also look at number of carbon atoms. There are 7 carbon atoms in long chain and 3 carbons in substituents. So 7 and 3 is 10. It is similar to this one, but as the name is same, so it is the same compound. Let's see number of carbons in B. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 carbons. It should be 10. Let's see in C. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 carbons, which is also wrong. In part D, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 carbon atoms. Let's do the long chain. So this is the long chain. You cannot take this one as long chain because this long chain has 2 substituents. So the longer chain must have more number of substituents always. Let's look at the substituents. We have methyl group and ethyl group. So 1, 2, 3, 4, 5, 6, 7. So 3 ethyl, 2 methyl, and in 7 we have heptane. There are 10 carbons and 22 hydrogens. So this is the structural isomer because we have same molecular formula but different names or different structures. So correct answer is D. Question 33. The diagram shows a simplified structure of coenzyme Q10. This is the coenzyme structure. Which row describes the structure of coenzyme Q10 correctly? We have to find out what it is and what are the number of pi bonds in one molecule. Let's see, the options are aldehyde and ketone. If we look into the structure, we can see C double bond O. This carbon attached to 2 alkyl groups, so it is a ketone. This is C double bond O, so it is also a ketone. This is carbon bonded to oxygen bonded to carbon, which is ether. This is not in A levels syllabus, so ketone is the correct option. Second part is number of pi bonds in one molecule. This is one molecule actually. So let's see how many pi bonds are there. In double bond, one bond is always pi bond. So we have 1, 2, 3, and 4. 4 outside the repeating pattern. Now in repeating pattern, we have n number of pi bonds because it will repeat n number of times. So 4 and n. So it should be n plus 4. Correct answer is therefore D. Question 34. The molecule of limonene C10H16 contains a 6-membered ring. This is the only cyclic component in its structure. Which volume of hydrogen at room conditions is required to react completely with the double bonded carbons in 1 mole of limonene? So we have to find how many double bonded carbons are there in this structure. C10H16. Let's first make C10. So there is a 6-membered ring. 1, 2, 3, 4, 5, 6. And then 4 carbons are without ring. So let's suppose these are the other 4 carbon atoms present. Alright, let's see how many double bonds should be there. Now for alkene, it must be C10H20 if 1 double bond is present. Cyclic also means reduction of 2 hydrogen atoms. So you can say, let's suppose this is cyclic. So then minus 2 hydrogen for 1 double bond, it will become C10H18, and then minus 2 hydrogen for another double bond. Now it will become C10H16. So there are 2 double bonds and 1 cyclic structure. Okay, so 2 double bonds, we can put double bonds anywhere. Let's suppose these are the double bonds. Rest are the hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have structure C10H16. Let's react it with hydrogen. Now addition will take place and hydrogen will be attached to double bonded carbons. Double bond will be converted into single bonds. Alright, so same hydrogen atoms as before. Now hydrogen atoms get itself attached to double bonded carbon. So there will be 4 more hydrogen atoms. 1, 2, 3, 4. The formula should be C10H20. Alright, let's balance the equation. We have C10H16 and C10H20. So we need 4 more hydrogen atoms. So we can multiply this part with 2. So 1 mole of this structure requires 2 moles of hydrogen. At room conditions, 1 mole is 24 decimeter cube. So for 2 moles, it will be 48 decimeter cube. So this is the volume of gas, hydrogen gas required. Question 35. 1-bromopropane reacts with hot ethanolic sodium hydroxide. What is the molecular formula of the product in this reaction? So hot ethanolic sodium hydroxide causes elimination. In halogen alkane, we have propane, 3 carbons. 1 bromo means bromine is on first carbon. Rest are the number of hydrogen atoms. In the presence of ethanolic sodium hydroxide, elimination occurs. So in elimination, bromine is removed from 1 carbon, hydrogen is removed from adjacent carbon. HBr is lost in the form of NABr and H2O. This becomes alkene. So CH2 double bond CH single bond CH3 plus NaBr plus H2O. Okay, it says what is the molecular formula of product. So we have 3 carbons, 6 hydrogens, so it should be C3H6. Correct answer is A. Question 36. A sample of pent 2-ene-4-ol, which is C5H10O, contains all possible stereoisomers of this compound. How many stereoisomers are there in sample? For stereoisomers, we can look for cis strands, we can look for optical. Let's draw the structure. We have C5H10O. Pent means we have 5 carbons. Two ene, double bond between second and third carbon. 4-ol, which is on fourth carbon. Rest of the hydrogen atoms. For cis strands, we can look at double bonded carbons. For optical, we can look at chiral carbon. So chiral carbon is the one that is bonded to 4 different groups. All 3 are hydrogen. This is making a double bond. This is making a double bond. This carbon is attached to OH, H, CH3 and this side. So all 4 sides are different. This carbon is not chiral. Alright, so let's see whether this shows cis trans isomerism or not. So with double bonded carbon, we have 2 different groups. With double bonded carbon, we have 2 different groups. So yes, it shows cis trans, it shows optical. So according to formula 2n, we have cis trans as well as optical. So 2 raised to the power 2 equals 4 isomers. So in total, there will be 4 stereoisomers combined. Question 37. Which pair of reagents react to form a product with chiral carbon atom? Alright, so we have different reactants. Let's do the first one. First one is alkene, CH3, CH, double bond CH2 plus HBr. Now hydrogen will attach itself to the carbon having more hydrogens and bromine to the other carbon. So product will be CH3, CH, now Br, then CH2 and another hydrogen. So HBr is added. Now let's look for chiral carbon, which is the one attached to 4 different groups. So this carbon is attached to hydrogen, bromine, a CH3 and another CH3. So these 2 sides are same, so there is no chiral carbon. Second reaction, CH3, CH3 bonded to C double bond O. This is a ketone. NaBH4 is reducing agent, so it can reduce ketone to secondary alcohol. So CH3COH, H, CH3. This carbon is attached to OH, hydrogen. CH3 is similar to CH3, so no chiral carbon is present. Alright, so third option is an aldehyde. CH3, CH2, C double bond O, H plus HCN. So addition reaction will occur and hydrogen goes to this oxygen, CN goes to this carbon. So we have OH and CN. Let's look at this carbon. So it is attached to OH, hydrogen, CN and ethyl. So all four sides are different. So this could be the correct option. Then we have carboxylic acid and alcohol, CH3 C double bond O OH plus 2 carbon alcohol OH with CH2 and CH3. They will combine together to form ester. Water will be removed and these two will attach together by the help of oxygen. So now we have CH3 C double bond O O CH2 CH3. None of the carbon atoms is bonded to 4 different groups, so there is no chiral carbon. Correct answer is C. Question number 38. The diagram shows the structures of two esters. We have ester X and we have ester Y that are formed in ripening apples. Ester is C double bond O, C double bond O, oxygen. Which carboxylic acids are formed when these esters are hydrolyzed by sulfuric acid aqueous? Now, upon hydrolysis, what happens is that carbon single bond to oxygen breaks. The part which contains C double bond O becomes carboxylic acid. Same thing will happen for this one, and this part will become carboxylic acid. So let's see how many carbons are there. There are 1, 2 carbons. So it will become 2 carbon carboxylic acid, CH3 C double bond O OH. This part contains 1, 2, 3, 4 carbons in long chain and methyl group at second carbon. So we have CH3, CH2, CH, COOH and a methyl group on second carbon, 1, 2. Okay, let's see. Ester X forms 2 carbon carboxylic acid, so these two options are correct. Ester Y forms this part, which is not 3 carbon. So it is this one having 4 carbon atoms in long chain and 1 CH3 as a substituent. So correct answer is B. Question 39. An addition polymer is made from monomer Z. What is the structure of the polymer which is made from this monomer? We know in addition polymerization, double bonded carbons become the backbone of polymer. So only these two are involved in the long chain. This is the side chain substituent. It is not going to be the part of long chain. So only these two carbons are present. When it forms polymer, one bond is formed on the left side, one bond is formed on the right side, and double bond converts to single bond. So we have these two carbons having 2 hydrogens on this one hydrogen and one this group with the other carbon. So this is C double bond O O CH2 CH3. Now when pi bond breaks, one bond forms on left side, one bond forms on right side, and it repeats n number of times. So this is the structure of polymer. Let's see, in part A they have continued this part in the long chain, which is incorrect. In part B we have C double bond O, part of long chain, wrong. Again in this one they have made 3 carbon atom long chain and alkene is still there, incorrect. So 2 carbon atoms are present in long chain and this is the side chain. This is correct. So answer is D. Question 40. Compound X reacts with acidified potassium dichromate to form compound Y. IR spectrum of compound Y is shown. This is the infrared spectrum and these are the absorption ranges. What is the identity of compound X? So first we have to oxidize compound X to form compound Y. Let's see, we have propane 1-ol, which is primary alcohol, so it oxidizes to propanoic acid. Propane 2-ol, if oxidized it becomes ketone, so propanone. Propanone is a ketone and propanoic acid is already carboxylic acid. So ketone cannot be further oxidized. Carboxylic acid cannot be further oxidized. So C and D is incorrect. We only have two options, either A or B. So let's see what is present as compound Y. Is it propanoic acid or is it propanone? Let's look into the structure. So we have two main peaks. One is this one, C double bond O, and one is this part, OH. C double bond O is at 1700. So it could be any one of these. Could be amide, carbonyl, carboxyl, or ester. And OH 25 to 3000 and 32 to 3600. It could be carboxyl or hydroxy. So let's see, we have C double bond O, we have OH as well. So it could be carboxylic acid, not ketone, because both are present. So propanoic acid is correct. Answer is propane 1-ol. Thanks for watching. If this was useful, please do like, subscribe, and share.